Hello. So at the end of the last video, I gave you this question. What is the probability of tires wearing out between 32,000 and 37,000 miles? So we need to calculate this probability. And as you know, we are going to transform x into z. So you don't need to touch this term, but you have to transform the other numbers in the same way. So subtract the mean, divide by standard deviation on the left term, on the right term. And then the left term becomes minus 0.6 and the right term becomes plus 0.4. So because there is no difficulties at all, because you know mu is 35,000 and sigma is 5,000. And then we have to calculate this probability from the normal distribution table. But you need additional step to convert this probability between 2 points into difference of two cumulative probabilities. So probability between minus 0.6 plus 0.4 equals probability up to 0.4 minus probability up to minus 0.6. So you have to find this probability and then find this probability. So use calculator twice and then take their difference. The answer is 38.117%, right? So so far we have considered three types of probabilities: smaller than something, greater than something, and between 2 points. So the first type of probability is the cumulative probability, which is directly given by the CDF, cumulative distribution function, which is the normal distribution table. So it's not a big problem. But for the other two types of probabilities, you have to convert the probability back to a cumulative probability so that we can use the standard normal distribution table. Okay, and so this is a summary. If you are interested in probability smaller than A, then you are going to get this. If you are interested in probability greater than A, then you will be transforming this probability like this: 1 minus probability, cumulative probability, and then probability between A and B can be written as A cumulative probability minus another cumulative probability. So like these, the three types of probabilities all can be transformed and converted into cumulative probabilities. That's what we learned. And the last topic in this chapter we have to cover is this. Now we are going the other way. We are going inverse. That is, the probability is known. We know that 90% of tires last longer than a certain mile. What is that miles? So we want to say a sentence like this: 90% of tires last longer than blah blah miles. Like, so suppose you are doing advertisement. So then you have to say something like this. Then what is the number that you can use here? How can you do that? So we know the distribution of x, and now what we have to think about is this equation. Probability, what we want here is, so let's translate this: probability that a randomly chosen tire lasts more than a number of miles equals 90%. So 90% of tires last more than A, right? So this sentence can be translated into this equation. And then so this is the starting point. Given this equation, what we are going to do here is we are going to standardize x here. We will standardize x into z, but the problem here is a is unknown. So when you standardize x, of course you have to standardize its counterpart a, right? However, a is not a number. A is what we need to solve for. It's unknown. So even if you need to standardize it, but you cannot calculate that, then what you have to do is we are going the other way. Starting from the standard normal distribution, you have to find this value that makes 90%. So probability is not standardized. What you standardize is the numbers inside probability, but not the probability. So these two probabilities will be the same, and their relationship is standardization. So now after that, you match these two guys, A and B. So let me show you. Let me show you what exactly I'm talking about here. So first, we have 90%. 90%. We would like to find this probability, this number, miles. So probability x greater than a can be standardized this way, right? There is no difference, but the major difference is in a. So you know mu and sigma, but a is unknown. We are solving for a, so you cannot go any further. This is it. So this is it, but leave it as it is right now. But what we have here is, probability of this probability equals 90%. This is what we had from the question. And then we are going to find 90% from the normal distribution table or from a calculator or Excel. If you go the other way, 90% implies minus 1.28%. Oh, not percent. So like z greater than minus 1.28 gives 90%. So from 90%, you have to find minus 1.28. I demonstrated what Excel formula you need to use to find this. Right? And then what we can do here is we have two same probability, same 90% probability, and both of them have same standard normal distribution random variable. Then because they have the same probability, 90%, minus 1.28 equals this guy. So from these two probability statements, you can deduce that like this. This guy should be the same as this guy, right? So write down the equality, and then it is easy. You can solve it for A. So multiply 5,000 on both sides, or move the denominator to the other side, and then add 35,000 on both sides to cancel out this. And then in the end, you will get this. That is your the answer, right? So remember, we are matching these two guys, and in the end, we get this. Excuse me. And you may interpret this using the standardization idea. So think about this. Minus 1.28 means it's below. Minus means below average, and how much? What's the distance from the average? That is 1.28 standard deviation. So if you go down by 1.28 from the mean, then you will get 90% above. That means, so from the mean is 35,000, and you have to subtract minus 1.28 standard deviation, which is 5,000. So from the mean 35,000, you have to lower the bar by 1.28 standard deviation, which is this much. So if you calculate them, you get this number. So that's the cutoff for 90%. So 90% of tires will last more than 28,600 miles. That's what we got in the end. So now let's try another thing on the same structure. We are going to find this number. Say, for example, in a safety, in your manual for safety, you may need to say something like this: 95% of tires cannot last up to this miles. So do not drive more than this much miles. For example, if you want to say something like that, you have to find number coming up here. So the clue is 95% of tires cannot last up to this miles. So smaller than this miles. So you can write it this way: probability that a randomly chosen tire smaller than cannot endure A miles is 95%. 95% of tires wear out before A. And then standardize this probability. Standardize inside the probability. So standardize X into Z and A into A minus mu over sigma. Then you get this. And again, we do not know A, so we cannot do anything more than this. So this is it. But you have to utilize 95%. Using the information 95%, you have to find this number that satisfies the same structure. Z smaller than something should be 95%. So you have to find this number from the normal distribution. And remember, 95% of tires are below this point, which means this point is top 5% value. And remember, top 5% of value was denoted this way and was given as 1.64 in the question. So top 5%, we are looking for top 5% value. So you have to use that number. And then match those two. This probability and this probability have the same 95% and same structure. So A minus 35,000 over 5,000 equals this, which means this A should be 1.64 standard deviation above the mean. So mean is 35,000 and add this much miles. How much is it? 1.64 times 5,000, which is the standard deviation. So then you will get 43,200 miles. So this is how we again use the standardization process to calculate percentiles for non-standard normal distribution. So simply, in conclusion, we only need the standard normal distribution. So using the standard normal distribution, you can cover any kind of normal distribution. So that's a very nice property of a normal distribution. So a summary, intermediate summary, what we just learned is, given P, you'd like to calculate A, then standardize A first, and then find B that satisfies this equality, same structure, and then match them. And then in the end, you will get like A equals, so average plus or minus standard deviation. So you have to think it as that way. Standardization means from the mean, how far is the observation in the units of standard deviation. So that's what you can find here. And final summary, we have learned how to calculate these guys for any non-standard normal distribution. So this is the end of chapter 6, and I'm going to start chapter 7 in the next video, and we will briefly I will only cover introduction, but it's very closely connected to this chapter. Chapter 7 and the following chapters are all based on the normal distribution theory. So you have to make yourself familiar with these techniques. So you will need to use these techniques in every homework from now on. So good luck and see you in the next one.